So the first thing we want to do is we're going to create a dictionary called copies. And then we're going to write the code for the first pass, right? And the first pass, our job is just to create copies and save them in the dictionary. So we're going to have a variable called node, and that's going to be pointing to the hid node. And then we'll write a while loop, which is going to increment our node one at a time until we reach the end of the list. And each iteration, we're going to create a copy of the node. So we create a new node with this node's value, the next, and the random. And then we're going to save that in the copies dictionary. So the new node is going to be the value, and the key is going to be the old node. And then after that, we're going to do our second pass, which is where we're going to fix all the links. We reset the variable node. That's going to go back to the start of the list. And then just like before, we create a while loop looping through each element in the list. And what do we do per iteration? First of all, we want to grab the copy of the node that we made in the first pass. So node copy is equal to copies node. And once we have that node, we also need to fix up the random. So for the next, we want to set that to the copy. And similarly for random, we also want to set that to the copy. And in the end, we want to return the copy of the hid node here. And that's pretty much the code. One last thing, it's that say node copy.next is equal to none, like this node number 5 here is equal to none, or the random is equal to null, like the 3 node here. And in that case, when we try to look up none in our copies dictionary, it's going to give us a key error because none doesn't exist in our dictionary, right? So in order to avoid that error, I'm going to put a mapping for none, and that's going to return none. So as we're fixing the links, if the node's next or the node's random is equal to none, then we just leave it be. It's going to stay none. And that's really the code. Let's give it a run. And there you go. For the time complexity, we're doing 2 passes through the list, and within each iteration, all of our operations are O of 1. So in total, our time complexity is O of n. As for the space complexity, we have a copies dictionary, and the copies dictionary is going to store every single node in the linked list. So copies is also going to be size n. So overall, time and space complexity are both linear. All right, thanks for watching. Okay, bye.